All right, section 1.3, we're looking into complex numbers. And complex doesn't mean like they're complicated. It simply means that they're kind of like attached to something. Think about the idea if you live in a housing complex, you know, your house doesn't stand alone. So something else causes this to happen. So we'll get a little bit more into that, and I'll explain as they come up. But this first problem wants us to rationalize the denominator. All right, so we have 7 divided by 4 plus the square root of 15. All right, so the denominator is the bottom. We want to rationalize it, which means we want to simplify it in such a way that we do not have this square root in the bottom. We don't like to have square roots in the bottom. We don't like to have imaginary numbers in the bottom because they come from square roots. So it's essentially the same. So the way that you get rid of a square root or you rationalize the denominator is we use the conjugate. So you may want to recall the difference of squares formula, a squared plus b squared, sorry, not a squared plus b squared, I'm thinking of Pythagorean theorem. Let me just start over. A squared minus b squared. So if you have something of this form, it can be rewritten or factored in the form a plus b, a minus b. And the order doesn't matter. You could do a minus b and then a plus b. We're going to be using a similar property to conjugate the denominator, or to rationalize the denominator. I'm using the term I want to say. So whatever you have in the bottom, normally you have two terms. There are some other instances that get a little bit more complicated, but for right now we're focusing on two terms. If you have two terms, you have to multiply by what they call the conjugate. So conjugate comes from this idea of difference of squares. So that when you multiply the same two terms but you change the sign, you end up with something squared, and when you square a square root, it's no longer there. So we have to multiply by the conjugate. So for example, if I gave 2 minus the square root of 6, okay, its conjugate would be 2 plus the square root of 6. And if I gave something with addition, let's say 5 plus square root of 7, its conjugate would be 5 minus the square root of 7. So it still comes from this idea, difference of squares. You have to have the same two terms, you just change that middle sign. So we're going to apply this conjugate to this property. We're going to multiply by 4 plus the square root of, 4 minus, keep messing up my signs, 4 minus the square root of 15. We have to do that to the top and the bottom to keep this same, to keep this problem the same. All right, so mathematicians are lazy. We look for the easiest, simplest way to do things. So you can FOIL this out and do distributive property, or you can just consider, oh, this is just difference of squares. I'm just going to end up with those two terms squared. All right. So on the bottom, that's exactly what I'm going to do. I'm going to square the first term, and I'll multiply it out below just so you can kind of see what's going on. But you'll save yourself some work at the end of the day if you apply this difference of squares idea to the conjugate. So if you square that first term, that's 4 squared, that gives you 16. And if you square the square root of 15, it gets rid of the square root. the sign is always minus, and we get 15. So it just gets rid of that square root. On the top, you actually have to distribute 7 times 4, 28, and then 7 times this negative square root of 15. So since this 7 is not inside of a square root, you don't multiply it times 15, it just gets attached to the outside. So if there was a number in front of here, you would multiply 7 times that front number, leading coefficient, or the coefficient. So in this case, 7 times the negative square root of 15 will give you minus 7 square roots of 15. All right, so we have rationalized the denominator. Now we just need to simplify. So on the top, these are not like terms. We cannot simplify that. On the bottom, 16 minus 1 gives us, 16 minus 15 gives us 1. And anything divided by 1 is itself. So you end up with 28 minus 7 square roots of 15. This is what you end up with when you rationalize the denominator. Now, let me actually FOIL this out. I want you to see, if you FOIL this out, how do you end up with just this, in case you don't really follow. So if you FOIL this out, and it's a lot more work, but if you need to do it, then do it if it helps. And then the more you do it, when you see it, you'll kind of be able to go to that shortcut. But mathematicians, we're generally lazy. We look for every shortcut we can find. All right, so we're going to FOIL this out. 4 times 4 will give us 16. And then 4 times this negative square root of 15 will give us negative 4 square root of 15. So I'm done with 4. I've multiplied 4 times both of these. Now I'm going to do 15 times 4. Positive 4 square roots of 15. And then square root of 15 times the square root of 15 will give us the square root of 15 squared. All right. And then these two middle terms are the same. They both have 4, both have this square root of 15. This is kind of acting like a variable. Like if you have minus 4x plus 4x, they both cancel out. And then you're left with 16. And then square root and square cancel each other out. This actually should be negative. I don't know why I put plus, because a positive times a negative, that should be negative. So I got to be careful. So that's how you get the minus 15. All right, and so that's the work that you would go through to get here, or you can just use this and just jump straight there. But rationalize the denominator. This is what we get: 28 and negative 7 square roots of 15. All right, so 28 minus 7 square roots of 15. Okay.